This is a pretty simple question which involves certain basic concepts. We have been given 3 capacitors and these 2 cells of 6 volt each. We need to find out the final charge on the 3 capacitors. So for solving this question, there is a general method. Assume the potential at this point to be 0, the potential at this point becomes 6, this point also the potential becomes 6, and let the potential at this point be equal to x. So let me draw the plates again here. For capacitors, you can always use this method. The potential at this point is 6, this is x, this is again 6, and this is 0. So the charges can always be written like plus minus 6 minus x into the capacitance, that is 2. This is plus minus x minus 6 into 4. If you are assuming this to be plus, we have to write the potential over here of this point first, that is 6 minus x, therefore this point becomes plus. Here we write plus minus x into 5. So now we see that, let us check this system of 3 plates. These 3 plates are not connected to the outer system, therefore there is no way this system loses charge to the outer system or gains charge from the outer system. Therefore the net charge on this system of 3 plates should be 0. Therefore we write it down like that. We get minus of 6 minus x into 2, that is because there is a negative charge of this much on this plate, plus x minus 6 into 4 plus 5x, this should be equal to 0. So we get x is equal to 36 upon 11. So once we get x, we can easily get the charge on all the plates by putting the values of x over here. So on putting these values, we get for the 2 microfarad capacitor, we have the total charge is equal to 6 minus 36 upon 11 into 2, which comes out to be equal to 60 upon 11 microcoulomb, mind you, because this was microfarad. So the charge on 2 microfarad capacitor comes out to be equal to 60 upon 11 microcoulomb. On the 4 microfarad capacitor, it comes out to be equal to x minus 6 into 4, that is 36 upon 11 minus 6 into 4, that is equal to minus 120 upon 11 microcoulomb. That is, it is coming out to be plus minus 120, that is, it is actually plus minus 120 microcoulomb upon 11. So our answer for 4 microfarad capacitor comes out to be equal to this. For the 5 microfarad capacitor, we have this to be equal to 5 into x, that is equal to 210 upon 11 microcoulombs. Sorry, it is 180 upon 11 microcoulomb. So final answer comes out to be equal to the charge on 2 microfarad capacitor comes out to be equal to 60 upon 11 microcoulomb. On the 4 microfarad capacitor comes out to be equal to 120 upon 11 microcoulomb, but in this fashion, plus minus, and on the 5 microfarad capacitor comes out to be equal to 180 upon 11 microcoulomb. There is another method which you could have used, that is, you could have written down it in this fashion. Instead of doing it by potential, you could have done it by charges, that is, let the charge on this plate come out to be plus q, this will be plus q1, this will be minus q1, let this be plus q2, this will be minus q2. Now since this is minus q1 minus q2, by conservation of charge on these 3 plates, this will be q1 plus q2, so this plate will be minus of q1 plus q2. Now there are 2 variables that we have, so now you can assume this to be 0, this to be 6, this to be v, this becomes 6. So now you can write 3 equations like 6 minus v is equal to the potential difference across this capacitor, that is equal to q is equal to cv, therefore the potential difference is equal to q upon c, therefore we get this as q1 upon 2. We will get another equation from here, 6 minus v is equal to again q2 upon 4, and the third equation will be v minus 0 is equal to q1 plus q2 upon 5. So we get 3 equations, 3 variables. You can solve it from here. Otherwise what you could have also done is that you could have applied voltage conservation in these 2 loops. The total drop in voltage in this loop should be 0 and the total voltage drop in this loop should be 0, by which you would have got the equation in Q1 and Q2, two equations Q1 and Q2, and you would have solved it like that. Different questions are solved easily by different methods. So in this question I found the potential method easiest, so I used the potential method to solve the question easily.